discuss about the topics of ideal Rankine cycle. In before that, we should know about what is the base. The ideal Rankine cycle is the base working of steam power plant. Okay, the steam power plant, we know that with the help of the water converted into steam, again the outlet of the steam is being converted for amount of energy. It's like electrical energy. Yeah. The same thing here we have to follow. But today, this class, we have discussed about the layout of ideal Rankine cycle and then how we are going to draw the temperature and entropy diagram. Second thing, we have to follow the formula and then how we are going to appear this equation like this. Okay, the first one I will explain about the layout of Rankine cycle. From the ideal Rankine cycle, the major components of first one is like a boiler. So the boiler is addition of heat, but pressure remains constant. While the boiler, the addition of the heat, pressure remains constant. Here, the water already they have shown this boiler. We need to add the heat for continuous. Again, the water is like a liquid formation. The liquid turned into vapor with the help adding of the heat. After that boiler, the addition of the heat is converted to steam to supply for the transfer for the turbine. So the turbine is like an expansion process. From that expansion process, the initial and the final. Okay, from this one, with the help of the T's diagram, we can calculate the entropy diagram. It's like a first one, 1, 2, 2. The initial state is like a turbine expansion. The first condition definitely will be that for superheat or dry cycle because there is no moisture content present in the system. While here the steam is expanded to the turbine. Steam is expanded to the turbine. So there is no moisture content present in the steam. Here the 1 and 2 is the expansion of process. 1 and 2 is the expansion of process. It's like a turbine. So here is located for the turbine. The turbine initial stage for high pressure, high temperature of steam. So after the expansion, we have to go for the condenser. So already we know the condenser. We have to go for the condenser. So the condenser is like a removal of the heat, but pressure remains constant. Okay, the boiler, addition of the heat, pressure remains constant, and the condenser, the removal of the heat, pressure remains constant. So before entering the condenser, the condition of the steam is low pressure, low temperature of steam. After the condenser, again come for the third question, come for the low pressure, low temperature liquid. Because condenser, here we have to circulate the cooling water and then to absorb the hot gases. So definitely it will be change the phase change process. Phase change process. So here for the TS diagram, we will indicate for 2 to 3. They indicate for 2 to 3. And then 2 and 3. The pressure remains constant, but here only to change the phase change process like steam into liquid, vapor into liquid. So after that condenser, we have to supply for the feed pump. Here only to increase the pressure. Only to increase the pressure. There is no any addition divisor. Only to increase the pressure. So before the pump, before the feed pump, low pressure, low temperature of liquid. So once you enter the feed pump, again the exit of the feed pump comes from high pressure, low temperature of liquid. Because here the feed pump to increase the pressure at the maximum allowed pressure. Because here how much amount of pressure is increased, the same amount of pressure to obtain the turbine. So after that feed pump comes from high pressure, low temperature of liquid. Again the high pressure, low temperature of liquid to send to the boiler. It's like an inlet. After the boiler, you have to add the heat for continuous. What happens? It will convert liquid into steam. So exit of the boiler, It's come from high pressure, high temperature of steam. That high pressure, high temperature steam to obtain a turbine. It's like one recycle method. It's like one recycle method. Okay. So here we have to mention for 1 dash and 2 dash. So what is the reason? Once if we enter the turbine blade, definitely we have the two kind of steam here. One is the dry steam, or next one is the super steam. So the dry steam definitely will be set like this temperature 100 degrees Celsius. Temperature 100 degrees Celsius. So 100 degrees Celsius, we have to mention the point in this saturation. The saturation. Okay. So here this curve is saturation. From this curve we have to split up for two portions. The maximum is the critical point. So before the critical point, it comes from the solid plus liquid, and then again liquid plus vapor, and then vapor. So these like the 3 to 4, the third part is located for which condition like a liquid condition, and then here the 2 dash, and this curve is indication of vapor condition. Okay, so the initial condition it comes from dry saturated or solid. So here we have mentioned for two type of diagram. Dry saturated will be mentioned for the point 1, this on the line, and then superheated we have mentioned this point 1 above the line. If we come from that wet condition, but it's not possible. If you mention the wet condition below the line, okay, it's like a process. It's like a process. Here the boiler and then condenser. Here it's like ideal conditions of super steam or otherwise dry steam. The next one we will study about for how to mention the efficiency of form. Okay. So we have to draw the performance of parameters. The performance of parameters only question the calculation. So how here we are going to calculate the how we here we are going to identify these equations like formation of the formula. The initial we know that the basic efficiency output by unit. Here the output is part of our work done and the input is part of our heat supply. Okay. Obviously we have designed like this. The output of work done is like a turbine and the input of heat supply we can say efficiency is equal to work done by heat supply. Okay, this is the basics method.